We'll start letting folks in now. Thanks again, Roland. Welcome, everyone. It's great to see you this afternoon, this morning, whatever time zone, whatever part of the country you might be calling in from today. It's great to see everyone. We'll just wait a few moments here until folks continue to trickle into the call before we get started. Really excited to have another community of practice together with our amazing guest speaker, who I'll introduce in a moment, who maybe some of you know. And it's going to be a good time. This meeting is also recorded and will be shared on Nature Canada's YouTube channel in a few days. So if folks from your team, from your community, or anyone else that you might know is interested on this topic, it will be available afterwards to watch anytime on YouTube. So just as a quick reminder, please just remember to stay on mute during the presentation or at the end when we take questions when others are speaking. You're also welcome to use the chat for questions that you might have. And you're also more than welcome to keep your cameras on or off throughout the presentation, whatever makes you the most comfortable. And if this is your first Bird Friendly City Community of Practice meeting, welcome. I'm sure we might have met before, but if not, my name's Autumn Jordan. My pronouns are she, they. Nature Canada's Bird Friendly City organizer, and I've been at Nature Canada since May 2021. Got the amazing opportunity to do some marsh monitoring of swallows and other species at risk with our naturalist team. And since then, after that field season wrapped up, I've been working on the Bird Friendly City program since. And if you'd like to introduce yourself in the chat, say hello to other folks on the call, where you might be calling in from, that would be fantastic. And before we get into today's presentation, just wanted to take a moment to recognize that Nature Canada acknowledges the existence of Canada as the direct result of colonial practices that have negatively impacted Indigenous people for hundreds of years. There are currently more than 630 First Nations communities, 53 Inuit communities, and 8 Métis settlements in the country we now call Canada. Many of these individuals have inhabited this land since time immemorial. Their nations and people are from coast to coast to coast and play crucial roles in stewarding the land and protecting the species that we all rely on and deeply care about. Nature Canada is reaffirming its commitment to amplifying the voices of Indigenous peoples as traditional stewards, caretakers of the land, the water, and species that inhabit it. Today, I'm calling in from the unceded, unsurrendered territory of the Algonquin and Anishinaabe people, otherwise known as Ottawa. If you're not sure which territory you're calling in from today, I highly recommend checking out this awesome website. I can put the link in the chat. It's native-land.org, and you can find everything from whose territory you're on, what treaty that might be, what language they speak, and where else they historically were living in so-called Canada. And so with that, I'm really excited to introduce today's speaker, Roland Deschênes, Fellow of the Royal Astronomical Society of Canada, a member of the Royal Astronomical Society of Canada's Light Pollution Abatement Committee, and he's also the founding member of Calgary Bird Friendly City Team. As an amateur astronomer with over 40 years experience, he has been a popularizer of astronomy to the public for much of that time. His interests are astrophotography, meteorites, and light pollution abatement. He moonlights as an oil and gas geologist during the day. He was recently honored by having asteroid number 187 named after him. Oh my gosh, I love that. He runs the Society's social media pages, which I'll post in the chat shortly, that focuses on light pollution and the health impacts of light at night on health and the natural world. On top of this, he also runs the Support Dark Sky Facebook page, Songways Birds Facebook page, and is a contributor to Bird Friendly Calgary's Facebook page. And if you haven't heard of the Royal Astronomical Society of Canada's Dark Sky Sites program before, you'll get to learn more about it today. It aims to protect the natural dark night and raise awareness of the negative impacts of artificial light at night. A new certification category within the Royal Astronomical Society's programs is the Nocturnal Sanctuary, which aims to promote dark sky principles to protect nature even in urban settings. Though pervasive in our modern world, outdoor artificial lighting is a pollutant that is relatively easy to control if we can get past some of the irrational attachment to our beliefs that more light at night is better. I love that, Roland. So thank you so much for being here with us today. Thank you so much, everyone, for joining in on today's call. And I'll post those links in the chat. I'll keep an eye on the chats. And over to you, Roland.
All right, thanks, Autumn, and welcome everybody. I am presenting from Calgary, and we have our own land acknowledgement in this area. I'll let you read that. But basically, we're in Treaty 7 region of southern Alberta and Métis Nation districts 5 and 6. All right, so if you've been involved at any point on submitting an application to the bird-friendly city designation from Nature Canada, you've seen this part of the scoring rubric under threat reduction, and there's three kind of aspects to this on the light pollution side. And so we have 3 points that you can earn in this category from threat reduction on light pollution. And so why this emphasis on light pollution reduction and protecting birds? Well, to answer that, you need to know really what is light pollution and in the various forms in which it can occur. We also need to see how artificial light at night, ALAN, and I may well use that acronym in the talk, ALAN. No offense to anyone named Alan in the audience. This is just an acronym. And we also, besides looking at the hormonal aspects of that, we need to look at how behaviors of birds are impacted by ALAN. ALAN. All right, let's move on here. And so we live on a planet that has for billions of years had a day and a night, but somehow in the last 100 years we've kind of forgotten about that. And that's because we've created our own light sources to extend the daytime into the nighttime. Now we need that nighttime lighting for a number of reasons, and typically we think of visibility and safety, enhanced surveillance, and used properly, it can create attractive environments. But there's a downside, right? It can cause energy waste, negative environmental impacts, unsafe areas due to glare, ironic, since we're adding light to make things safer, and also an increase in nighttime crime rates. And I'm going to address that last point first, because this is a sticking point for a lot of people when we talk about light pollution and responsible lighting. It turns out that most studies find a very poor relationship between lighting and crime, but for sure we feel safer. And when the studies are designed properly, they actually imply a shift of crime away from the daytime into the night once lighting is installed. And when you interview criminals, looking at what caused them to target a particular site or something, they find that difficult entries, so locks, maybe bars on windows and so on, dogs and alarms, but not lighting as deterrence. For them, actually, lighting is maybe an advantage. You may be aware that with house break-ins, most of those actually occur during the daytime. So it's not a lack of lighting that's the issue. It's whether or not something is occupied or not. So the signs of occupancy is the clear determinant of the overall of whether a site's going to get targeted. Businesses do get targeted at night, but that's because they're unoccupied, not because they are dark. Now, light pollution comes in many forms. And typically when people think about light pollution, it's this first term, sky glow, and that's the light shining upward, brightening the night sky. But there's also aspects of light trespass, where the light is shining where it's not wanted, glare, light shining out at high angles and reducing visibility. We've got visual clutter, and that creates confusing situations. And of course, there's the overall arching waste, just using too much light. So to go through these one by one here, sky glow is that unnatural brightening of the night sky, making faint features such as stars, aurora, and the Milky Way difficult to see. And this is, of course, how it was my doorway as an amateur astronomer into start looking at the problem of light pollution, because it was starting to interfere with my ability to see the night sky. I subsequently realized that there's far more than astronomy being impacted by bad lighting practices. And the thing about sky glow is, even though the symptom is manifested in the sky, the cause of that is all sorts of poor lighting practices at ground level. And so you might have glare and uplight and too much intensity at ground level, creating that sky glow, but the sky glow is just a symptom, and you can go to the ground and try to impact and mitigate some of those problems. Glare and light trespass. Many problems are created by trying to do too much with one light source. In this case, we've got a building with a so-called security light. I always put air quotes around security. People feel safer with them on, but are they actually safer? Here, this lamp is sitting above a doorway, and it's shining out across a parking lot. And so you got one overly bright source, and you're basically trying to put light over some distance away from there, and these leads to these other problems of sky glow, glare, and trespass. So anything that's above the horizontal never hits the ground. And so that basically is waste energy going straight up into the sky, causing sky glow. There's a wedge out here when the angle is low enough that's basically just glare and is shining into adjacent properties. That's called trespass. If there was a person, say the neighbor, looking at this parking lot and the doorway, standing over on the left-hand side of this image, they would be basically staring into this bright lamp. They wouldn't be able to see any details of the person who might be trying to break in at the doorway there. And eventually we get down to the useful light. So that's only a small slice of all the light that's being emitted from this light source. And so this is the light that's basically now not causing glare and is illuminating the target for the illumination. So you got to ask yourself if you're really improving things by adding more light. In this case, I'd say they would have been better off with two smaller lamps with more direct light downwards and nothing laterally and upwards. That's glare. We're all familiar with that. Driving down a country road with a vehicle heading your way, there's twice as much light on the roadway between the two vehicles. Do you see twice as much? No. And that's because glare, which is a brighter light source in a relatively darker field of view, always decreases visibility, and it always reduces security and safety. So we really want to make sure about aiming that light in a way that reduces that glare impact, and to make it useful light and not actually reducing your visibility. Things that are, say, 10 times fainter than that light source in your field of view are very difficult to see any detail in. So I have a kind of like a 10-to-1 rule. If you can see a light bulb, chances are there's a lot of the scene that's below 1/10 that same brightness of the light bulb. If you shield that light bulb, now the threshold for the 10-to-1 drops much lower, and more of your scene will be visible without much difficulty. Visual clutter. Basically, too many light sources can overwhelm the visual system's ability to determine what are the important pieces of information in this scene. It takes a little while to sort out where the edges of the buildings are because of all of these lights on in this photograph. And so if you're a bird flying through a downtown area it can be very difficult to figure out where you need to be and where you shouldn't try to be. But we have the same problem as humans. Here's a lovely little diagram that I found. Basically looks at all the different way light can bounce around and shine in your suburban environment. We've got all the light trespass going straight into the windows, and who hasn't had a street light shining in their bedroom window? That's kind of problematic. You've got direct glare from a street light into your eyeballs, and the useful light is really the stuff that stays out of your eyeballs, and its most direct path is to the things you need to see, whether it's a roadway, a sidewalk, or some other thing. There's a health consequence here as well, and we have an internal biological clock called a circadian rhythm. And through receptors in the eye, nighttime lighting, or ALAN, disrupts the production of melatonin, which is that molecule there on the left, in the pineal gland, and that's the molecule that's like a conductor that regulates the circadian rhythm. And that circadian rhythm controls how key hormones fluctuate during a 24-hour period. These hormones influence diverse parts of the body, but for example, the immune system and hunger and weight gain and loss. The graphs on the right-hand side, we get to see how over the course of 2 days, the top graph shows how melatonin varies, and those blue vertical bars are the nighttime periods. And so melatonin increases at night and decreases during the day. And it's light mediated. In mammals, it's entirely through the eyes. Other species, such as frogs, also have receptors in their skin, and so that they are more sensitive to light, even if their eyes are closed. And for example, the stress hormone cortisol, the next graph there, we see that at night it builds up, and over the course of the day, we do various things, and we wear down and use cortisol over the course of the day until it's depleted just before nightfall, and then it builds up the next night. Growth hormone has a similar kind of thing as melatonin, but it's more restricted to the early part of the evening. Now, the trick here is to make sure all of these different processes do not occur at the same time. And that's what melatonin is trying to do as the conductor. You want your body to be active and alert and able to do things during the daytime, and you need it to kind of rest and restore at nighttime. And so you need these processes, which are sometimes directly opposed to each other, to not overlap in time. They need to be separated in time so they can each do their thing. The bottom graph show the immune system, and particularly the cells, immune cells in your body, and you can see how they vary across the course of the day and night as well. And I've just lined those two graphs up with the graph on the top. And so essentially, again, it is the melatonin molecule that is the conductor to make sure that all of these things do their things at the right time and not in opposition with each other. Now, that means, of course, that light pollution is potentially a health issue, and it was such declared in 2009 by the American Medical Association. And they basically declared support for light pollution reduction efforts and advocated for non-glare lighting. And so they had studied things like glare and visibility, the disruption of human and animal circadian rhythms, depressed immune systems, increases in certain cancer types, particularly breast cancers in both men and women are elevated. The risk of that is elevated at nighttime if you're exposed to a lot of light. So shift workers, or just anyone who's not able to spend a night in a natural dark situation. In 2016, the American Medical Association went a little further, and they specifically focused on the new technology at the time, which was the LEDs, which had a higher blue output. And I'm going to talk more completely about this issue with LEDs later on in the talk. But basically, they were saying that you should limit the um, color temperature of the outdoor lighting to a particular level, and we'll talk about that later. But basically, to minimize the amount of blue light. So the question then is, since this is a Bird Friendly Cities community practice session, how do we look at this in terms of birds? Do we see these effects in birds? Well, we'll start with a very familiar bird, the American robin, and it sings at first perceptible light. And in 1929, they measured over the course of the spring and early summer the onset of singing in robins, and basically developed this curve. And you can see that in June, when the sunrise is earliest, the birds would sing at their earliest point, a little after 5 o'clock. Now you go to 2003, and more artificial light sources have been introduced into the environment, and we see that pattern of June being the earliest singing is still more or less true, but now it's been deeply impacted by the amount of light at night. And essentially, all that light pollution makes the birds feel like the dawn is earlier, and they start singing earlier. So these birds are very attuned to that first glow of dawn in the morning prior to the sunrise, and with light pollution, that's a very big impact. Now that was 2003. The work hasn't been done much for later, but we do know something about the light pollution situation since then. And basically, in the last 20 some years, light pollution has really exploded. And that's because, paradoxically, even though LEDs are very efficient with light, we then think we have carte blanche to keep on adding more and more light at night. And so light pollution has been growing at values of between 5 and 10% per year. And so the issue would be much worse nowadays. So the question then is this a behavioral effect? Hey, I see light in the pre-dawn sky, I'm going to start singing. Or is this a hormonal effect where basically the body is primed to do this behavior because of hormones? Now, we don't have to study in the American robin to kind of sort this out, and presumably there's a little bit of both going on here. But we have a very closely related bird in Europe, European blackbird. This is the blackbird of 24 blackbirds baked into a pie, or 4 and 20, I guess the saying is. So it's another thrush closely related to the American robin, and in this case, they did measure the melatonin in the blood. And so with light at night, they found lower melatonin and greater pre-dawn activity, just like in the robins. And in wintertime, the light at night birds had lower melatonin concentrations early and late night. And in the summertime, those light at night birds, the Allen birds, had lower melatonin concentrations throughout the night. So very clearly, the hormonal system would be impacted by those low melatonin levels, because if melatonins are not, values are not varying through the course of the day and night, then they're no longer acting as that conductor to control the hormonal cycle. And so this is definitely a health impact on these birds. They also looked at whether the birds were rural or urban, and they found in the urban setting, with more light at night, first-year males, faster sexual maturity. Second-year males, paradoxically, no reproductive development and an irregular molt sequence. And the birds are just being stuck in a photorefractory state. Basically, that's the primary impact of not having a properly cycling melatonin level in your blood, and potentially chronic stress, right? If you're always awake, all of these things you're just not healthy enough to properly do these things like molt properly and things like that. So can light pollution create hormonal problems for the migrating bird? And yes, it's true. We can see some potential impacts here. And for migratory birds, the onset of migratory restlessness is triggered by day-night length. And if you impact the day-night length by having Allen, light at night, artificial light at night. You can impact that day-night length and also trigger when those birds might be ready for migration. If a bird is in a southern wintering area with Allen, they might trigger spring migration too early. And this is a problem because you have a mismatch then between the arrival of the birds and the food sources along their migration path, and also at the arrival of the summer breeding area. They may show up too soon for some of their food sources to be ready for them, right? Because the insects and so on will have their own time scales, which may be mediated by other things such as temperature and so on. In the fall, we've got the same sort of issues there, but now the birds are delayed by light at night. They don't realize the fall is hitting because the nights still seem relatively long to their melatonin cycles, and that could mean that the birds linger too long before heading south. And a study just came out a few weeks ago, August 21st, light pollution prolongs avian activity. And basically they used acoustic monitoring, 60 million detections globally, over 500 diurnal bird species, and basically light pollution prolonged vocal activity by 50 minutes. So roughly 20 or 30 minutes additional time singing, both in the morning and in the evening. And they found that light pollution responses were strongest for species with large eyes, open nests, migratory habits, and large ranges during the breeding season. But birds with large eyes and open nests, that's basically telling you, yeah, they're going to be more exposed to light at night. I'm going to switch gears a little bit here. We're going to talk about just the behavior of birds. Like I said, the singing of robins and other birds is probably a mix of both behavior and the hormonal impacts, but we can also see a bunch of things that are strictly just behavior from Allen, or artificial light at night. So we can see these impacts at different scales, and we can see them at large scales, where they might affect migration pathways, medium scales, and that's affecting layover site choices during migration, and potential attraction to hazards, and at local scales. And this is where we're specifically talking about window strikes. So why are birds such, so impacted by light at night when they're out there? And that's because most of our migrants move under the cover of darkness. 80% of North American migrants move under cover of darkness. And it's not just every night. It turns out there are some special nights where everything just lines up properly. So for half the nights, very little activity and less than 7% of all migratory bird action. We add another 20% to that of nights, and that's another 10% in the activity. We add another 20% to that, and we're almost at another 30% of activity. But it looks like more than half the birds are moving on just 10% of the nights in a migratory window. So that's when they're looking for particular things to happen, and usually it's a good clear night, no storm activity, clear because birds are using lots of different visual cues from the environment, and they use their eyes for navigation and so on. Those are going to be nights where the winds are probably favorable in their direction, so kind of broadly northwards in the springtime and broadly southwards in the winter or in the fall time. And so this is where we can see some major events happen, and sometimes the catastrophic events, because if the night starts out with good conditions and then the conditions deteriorate over the course of the night, a weather front moves through or something like that, that's when we tend to see some major bird mortality events. North America, with our different flyways, different birds choose a different way to fly through. We got a lot of waterfowl moving through the prairie provinces. Particularly ducks do also spend a fair amount of time flying at night. Geese and swans less so. A lot of the little land birds, typically warblers and sparrows, we don't have the high densities in the prairies. Southern Ontario is definitely a major uh, flyway there. Point Pelee and other areas along that area, region definitely see a high pulse of bird migration. So how does that relate to where the light pollution sources are? And we can see, and we can overlap these two images, and so we can see that um, particularly in the eastern part of North America and eastern Canada, there are a lot more light pollution sources, but that's not to say that elsewhere is not also fraught with hazards due to ALAN, artificial light at night. And why do these birds choose to migrate at night? For a lot of the smaller ones, it's these cooler temperatures. If you're going to fly a marathon, it's a lot easier to do that when you're not overheating. So you choose to fly at night when you've got cooler temperatures. But that also leads to denser air, which means birds will have more lift and therefore less necessity to expend energy to stay aloft. There's also less turbulence. We don't have that daytime heating leading to turbulence, so it's a lot smoother flight. And for many of these small birds, that allows them to avoid the main hawk and crow predators. You might say, well, what about owls? A lot of the owls are actually more focused on ground prey, voles and mice. So for a lot of these smaller birds, it's these hawk and crow predators that are the big issue. And there's another reason that they might choose to fly at night, and that's this possibility of star navigation. So we do know, and this has been demonstrated in one species, the indigo bunting, basically a type of finch, um, related to the cardinal and was one of the closest relatives. So indigo buntings, small little blue bird, don't quite fly exactly like as illustrated there, but they use star patterns near Polaris, the North Star. And what's going on is that these young birds are sitting in these open nests, and they learn this part of the sky. Oh, it's called the circumpolar sky because it's up every clear night. Now, of course, they're not telling them each other little stories about Ursa Major being the big bear and Cassiopeia being the queen of Ethiopia or anything like that. But those are the patterns they recognize and learn, and they also learn about the rotation of the Earth. So everything spins around Polaris. And so they can figure out whether they should be moving north in the spring and south in the fall from this part of the sky, which is visible every clear night. What happens though is that they may run across light sources. And so here's an older satellite image from 1997, but it shows the upward illumination coming from a number of major centers in Western Canada. And what this does then is scatter in the atmosphere. And so now we've got this contour map that kind of shows you the impact of those upward pointing light sources on sky glow. So areas with kind of yellow, orange, red, and white, there's very few fainter stars visible in those areas. And birds that rely on star patterns are going to be very confused in there. So they're going to lose this tool for migration navigation. And so we see the corridor with Calgary, Red Deer, Edmonton on the left-hand side. Of course, Seattle, Portland, and Vancouver on the left-hand side. And this thing that kind of looks like a slug in British Columbia, that is the Okanagan Valley, which is a very important bird flyway in that part of the area. It's a north-south valley. My sister works with a banding station in that valley, and so they do get a lot of migrating birds through there. So light pollution, and specifically sky glow here, has the potential for large-scale disorientation of nocturnally migrating songbirds. So let's move on to medium-scale effects. Migration pathways for birds. Lots of times birds are not only looking upwards, but they may be looking downwards, getting visual clues about the landscape below them. And in the time before artificial light at night, what we saw for light sources on the ground were actually reflections of celestial objects, whether it's starlight or moonlight, and you can then, as a bird, use these as pathways, as highways to kind of make sure you're not just flying around in circles. Here's an example of where something went horribly wrong for a bunch of birds that were doing exactly that. They were navigating through oil sands in northeast Alberta. The Athabasca River in that area is a very prominent north-south corridor, and a lot of waterfowl use that as a migration highway at night. But if you can't see the stars, and poor weather conditions mean you can't see moonlight or starlight reflecting off the water, what do you have to navigate if you're a water bird, say a duck here? So what they found on this particular night, we had poor weather conditions. It was kind of rainy and foggy, and so very poor visibility. And so we ended up with over 500 birds to land and die on these tailings ponds, which are basically oil-saturated ponds. Now, it turns out those birds landed there instead of on clean natural ponds, which are very abundant in there and intermixed with the tailings ponds. That there are naturally clean ponds, or they didn't even land on the adjacent Athabasca River, even though it's the largest water body in the area. And in fact, they didn't even land on the unlit tailings ponds. They landed in the tailings ponds where the lighting was there and was installed specifically to illuminate the tailings ponds to prevent birds from landing on those ponds. And under normal circumstances, that would have been the surveillance that the operators in the area would have been using to scare off the birds. They have a variety of techniques to scare off the birds so they don't land on these. But on that particular night, what happened was those lights actually ended up being the attractant to landing on that very deadly target. Also on the medium scale, you might recognize this. This is the Tribute in Light in New York City, which unfortunately happens to lie right in the time window for the fall migration, 9/11, so September 11, basically a week away from us right now. We'll have this Tribute in Light in New York City. And essentially what happens is the birds find the light area, fly into it, and don't want to leave it. And so they would flap around in the beam of light until they drop to the ground. So early on, when in the Tribute of Light, they were able to trap thousands upon thousands of birds. And in this photograph, all those little white dots that you see are birds flying around in the beams of light. Now we see the light because blue light scatters in the air. And I'm going to mention this again later on when we're talking about LEDs. But blue light scatters more, so you see it more laterally in this case, so the birds would detect these beams of light. With radar data, we can see what happens. Here is before the light is turned on. We've got about 500 birds estimated to be in the area based on the radar data. And then after 20 minutes, nearly 16,000 birds, so another additional 15,000 birds have moved into the area, flocking around the Tribute in Light. Now nowadays, they have spotters, and when the bird concentration gets too high, they turn off the lights for about 20 minutes, and those birds disperse, and then they relamp and continue until the bird population in the beams becomes excessive again. But this is a case of sort of medium scale where they're drawn in, and we see this more broadly with cities and towns, that the birds are kind of brought into the urban environment because they see that light, and for whatever reason they are attracted to be flying in that light. An example here from a small crepuscular or evening and dawn flying seabird, a little shearwater. And what we see, they put trackers on these birds, and on the left-hand side of the screen we see this satellite image of where the light from the seaside villages were, and you can see how the birds dispersed from a single point and ended up flying around some of these more urbanized areas along the shore. This is a problem for a lot of small birds. In Canada, we've got on the west coast, we've got murrelets. My sister studied marbled murrelets, but there's a bunch of different murrelets up and down the west coast of North America. And in eastern Canada, we've got close relative, little cutie patootie, the puffin. This photo is actually from Norway, because guess what? They have puffins there too, and the puffins do suffer the same problems with light pollution. But what happens is, as the birds are dispersing from their nests for the first time, these are young birds, naive birds, they're looking for, guess what? Moonlight and starlight reflecting off the ocean. That's their visual clue. And instead, what they're doing is they're landing on roadways which are illuminated by light. And so now these little birds running around on roadways are in danger of being killed by traffic. And so both in Norway and in Canada, in Newfoundland, what's happening is people are trapping these young birds and transporting them and re-releasing them safely out to sea. And so, we have these puffling patrols, pufflings being the young puffins. So this is another example of birds being attracted to light. And a lot of these small seabirds fly in the dusk and the dawn because, again, the bigger seabirds are there to either predate upon them or do something called kleptoparasitism, which is basically steal their food. And so they try to fly under cover of darkness as much as possible to avoid those larger predator birds. Zooming in a little bit, we get to more local scale effects, and I'm sure everybody on the call here is very aware of the Fatal Light Awareness Program, or FLAP, based out of Toronto. Basically, over 1 million birds are killed by colliding with buildings. Similar programs are running in Ottawa and in Calgary. And I think there's some smaller scale projects in Saskatchewan, both in Regina and Saskatoon, and a few other places across the country. But I think these are the three big programs, and I think the grandpappy of them all, Fatal Light Awareness Program, probably collects more birds than all the rest of the country together. And essentially what happens is volunteers go out first thing in the morning into the downtown areas of these urbanized settings and find birds that have collided with windows overnight and collect them. If they're injured, they are sent off to rehabilitation facilities. Very often they are deceased. That basically, try to find these birds and rescue them wherever possible. So why would you, as a bird, decide to fly into a window at night? And I have this idea, untested, but it's my hypothesis, and that is that a lot of our smaller songbirds spend their time in the boreal forest when they're nesting and in the summertime, and these are the areas where the young birds are being raised, and so they look at this setting and they go, well, do I fly into the dark areas or into the light areas? And naturally, if you're in a forest, you're going to fly into those light areas. And then the question would be, if you find yourself as a little bird in an urbanized setting, do you fly into the light areas or do you fly into the dark areas? Now, we would think that's pretty obvious what to do, but I think a bird has evolved quite differently. Even more local to most people on the call would be your own yard. And it turns out that even though the big urban bird rescue programs are focused on downtowns and tall buildings, actually most of those collisions with those buildings are probably happening in the bottom, let's say, 5 stories of those buildings. And that's pretty much where the birds are going to hang out because that's where the trees are in downtowns. They're kind of in the lower parts of those buildings. The upper parts are probably less problematic than the lower parts of those buildings. And about half the birds in any urban situation are going to collide with windows in residential neighborhoods because the bird populations are higher and there's more attractive environments for those birds. And so in your yard, we have a number of potential hazards. One is try not to illuminate without shielding, because you're just spraying light laterally. You're also creating glare for your neighbors. But also that is acting as an attractant for birds. So if you do illuminate, use shielding, only light where, and particularly when necessary. A light that's left on overnight is probably not doing as much value as you might think. Also, turn off indoor lights when possible, because those windows, again, are going to be attractants to birds. And if you've got curtains, please at least close them to reduce the ability of birds to think that that's another portal. If you're in that room, occupying the room, close those curtains to make the windows less attractive. And on the daytime, I can't go talk about window strikes without at least mentioning in the daytime, use these exterior window markings, such as Feather Friendly, for example, one of the brands that are available for that. They're very inobtrusive, but can make a big difference for birds. Single hawk or falcon silhouette stickers don't work, but this dot pattern at about a 5 centimeter spacing is perfect. Birds will now realize that this is actually some sort of surface and try to avoid that. So, back to the rubric. We've got all these different options here. You've got a light pollution strategy. Let's just focus on that. And I'm going to bring in some of the local stuff that we have worked on here with the local team when we were doing our applications. So we have a light pollution reduction strategy that supports actions to reduce light pollution, particularly during migratory seasons. And with the City of Calgary, we have a number of places where we found information around lighting programs. I've been involved at least as a consultant in the City of Calgary, on a number of these documents. So I feel like I'm a little bit behind the scenes on some of these, but we had a lot of different places. So if you're just looking at your town or community or city, say land use bylaw, there might be a bunch of other different places you might find it. Very often, in fact, we have something in our community standards bylaw talking about light trespass from one property to another. So there's a lot of different places you might be hunting to see if you've got something to give you those points for this part of the scoring rubric. Light pollution mitigation standards for all new developments and or retrofit programs to replace street lamps with energy efficient shielded fixtures. And so in Calgary, and again, I have fingers all over some of this, particularly in the public education side, when this started rolling out back in 2000. But we did a number of relamping. Initially, we had kind of those orange toned, high pressure sodium with a salad bowl glass kind of hanging down from the light standard. And those got switched over to a flat lens version of the same type of lamp, but half the wattage. So it was a big energy saving, and we reduced glare and light pollution, sky glow, quite a lot. And then in 2015, the LEDs were becoming a big thing, and they were replacing all the street lights with those. Now it turns out that light pollution, sky glow actually increased a little bit with that retrofit because the blue content of the LEDs was scattering more in the atmosphere than the original, more kind of orangey toned high pressure sodium. So we'll touch on this blue LED issue a little bit here later. And then you got your outreach campaign, and particularly, we've been doing lots of public events, Migratory Bird Day. Autumn's going to mention some of the fall Migratory Bird Day after this talk. Things like Lights Out Toronto. We have now a Lights Out program in Calgary, and so this is one of our posters talking about this. And so we have a spring window and a fall window for a Lights Out program, and we've been getting pretty good traction with press releases with the media, probably dealing with 3 to 5 different media outlets each time we send out a seasonal lights out news or press release. So it's going well, I would say. So some next steps that was hinted in the title of this talk, and here's where I would like to go a little further than some of the things that we see in the scoring rubric, and maybe over time these might be things that we can add on into the bird-friendly city scoring rubric here. But basically, we want to convince our municipal officials and admin to not only use the fully shielded lighting for roadways and buildings, but to maybe implement a curfew on lighting in certain situations, like business signs after 11 p.m. or after they are closed. Lot lighting for municipal lots or businesses, that might be something that could be turned off or dimmed. The technology exists now with LEDs that you can dim them. And certainly if a park is closed after 11 p.m., why encourage people to use the parking lot with light? And again, I'm going to remind you that light at night is not necessarily a crime deterrent, and it might in fact increase your risk of nighttime crime. So that's one thing I'd like to see a little bit happening, some sort of curfew. And the other thing here is the limit of the amount of blue in outdoor luminaires. Uses 3000 K or lower, and that's an equivalent temperature of a black body. We'll talk about, again, the colors a little bit in a second here. But basically, by minimizing the blue, you lessen that impact on circadian rhythm. It reduces that sky glow because it's going to be scattering less in the atmosphere. And a new thing that I think not everyone's probably aware of, but it'll actually improve your visual acuity at night, because everyone's eyes are nearsighted in the blue wavelengths that those LEDs put out. And so I'm going to touch in on that a little bit. Turns out, maybe you played with a prism in junior high or high school, and you were able to split white light into a little rainbow. Well, the situation is with your eyeball is that lens is basically not perfect, and it won't focus all the wavelengths exactly in the same place. And when your pupil is wide open, the prism effect is much larger. And as I mentioned, we're all nearsighted at deep blue wavelengths. Now, the way the material in our lens and cornea are working, it turns out that the red through green kind of colors actually are a little bit closer in focus with each other than even this illustration shows, but the blue is way off. And so the blue basically ends up being a halo of blur or confusion around the sharp image that the rest of the wavelengths create. So if you minimize the amount of blue, the less you've got of that halo. It turns out the problem also exists kind of laterally. So it's not just that it splits it into a rainbow, is that the way the eye focuses light from a single beam of white light, you'll see a lateral shift. And again, the red through green part of the spectrum actually don't shift that much compared to each other, but blue is quite an outlier. I'm going to show that the next slide will probably prove that to you. If this looks slightly three-dimensional to you, where the blue looks a little further away or the red's a little closer to you, that's the effect that we're talking about here. So if you're driving around at night and you have your pupils wide open, the impact here, the offset of these two colors is going to be even greater at night as you're driving around or walking around. And so if you've got a lot of blue wavelengths that the LEDs put out, you're actually going to have a greater shift. And so even here, when everyone's eyes and their pupils are fairly well adapted to the light levels in their room, you're probably still seeing this three-dimensional effect here on this chromostereopsis. So I keep talking about LEDs and so on, and I've mentioned high pressure sodium or HPS, and that's the color difference between those two. A lot of people find the cool white LEDs quite harsh, and they like the warmer tones. And so what we're trying to do here is trying to understand how the lighting works with your eyeball, with your lens, and the different outputs. So our eye actually has like a day sensitivity curve, and that's our three colored spectrum. So that just gives us our cones with their three different lighting, and they have a broad envelope of day sensitivity. Our nighttime vision isn't color vision, but it's monochrome, but the night sensitivity is actually shifted more into the blue-green end of the spectrum. We have the output in the solid black line. That's the typical output of a cool white LED. And so it has a very strong, narrow blue peak at around 460 nanometers typically, and a broad hump where we take the blue wavelengths from the LED, and the actual LED is blue, and then we have these phosphors that convert over to these longer wavelengths. And so at night, our night sensitivity is actually peaking right where the LED is giving out very minimal output at around 500 nanometers. And so what we rather see is our night sensitivity and the LED to be a better match. We also have our circadian sensitivity, which is that dashed black line, and that's what controls our melatonin levels. And look at that match between that and the blue peak from the LEDs. So there's our problem. The LEDs are really attuned to messing with our circadian sensitivity. So here's our LED spectrum again. We've got the color output from that sitting on both sides of the peak of the human nighttime visual sensitivity, which is the green line. But it does match that now the circadian sensitivity. So we'd rather not see this type of LED. Now we can change the LED. We can tune that by using more or different phosphors to convert more and more of that blue wavelength light to these longer wavelength light. And so what we can do is we can bring down that peak with the warm white LED. So we minimize the circadian sensitivity. We push more of the wavelengths into the matching the day sensitivity. We're still not really getting good matching onto the nighttime sensitivity with LEDs, but this is a far better situation for us. We minimize the out of focus blue, so we don't have that blurry halo or blue around things. And the other thing, the same cells that are responding to control the melatonin, responding to that blue wavelength, those are the same cells that are responding to glare. And so if something seems harsh and hurts your eyes, it's because the blue is too intense. There's too much blue. And so by using warm-toned LEDs, we're perfectly good. We reduce the amount of blue light. Basically what this means, though, is if you're choosing LEDs for your home use, if you're doing them in the daytime, having a lot of blue light is not bad. It keeps you alert and so on. But it's the evening light that we really need to be aware of at home. And so there's where you want your warm white LEDs. So if you've got your living room or your bedroom, use the warm white. Still minimize the amount of use of light at night, because all light is can partially mess up your melatonin. Office work, morning, everything like that, great to have a lot of blue. It's actually advantageous to have a good pulse of blue. And so for people who have seasonal affective disorder, a good pulse of blue light first thing in the morning is actually just what the doctor would order. I mentioned color temperature, and here's where we can kind of compare here on the left-hand side of this screen. We've got what we would call warm tones through cool tones, but it turns out if you're heating up a piece of iron to 1900, that's actually at the, what we would call a warm tone light. That's actually relatively cool for black body radiation. Sunlight is around just under 6,000. So light like that during the daytime in your office, that's perfect. You wouldn't want that in your bedroom. And so, we can tune LEDs and make them with different color temperatures. Now, the American Medical Association was talking about using 3,000 Kelvin as a cutoff, and it's kind of a slightly yellowish white tone. And we would argue that depending on whether you need full proper color, it might actually be more advantageous for streetlights to be below 3000, more into the orange tones. The old high pressure sodium actually was a lot closer to 1900 Kelvin, to about 2000 Kelvin. And so there was a lot more orange toned wavelengths there. And it was actually quite restful on the eyes. On the right-hand side of the screen, from Travis Longcore, a longtime researcher on the effects of ALAN on the natural world, we see the sensitivity of different groups of animals to light at night. Most animals are less sensitive to negative impacts from red light, much more sensitive to those on the blue side. And so basically, in this case, the total level of the graph is how sensitive you are, and the slope of the graph tells you the difference between your sensitivity to red or blue. So mammals are actually quite sensitive to the blue, so it's got a very steep line, and but other animals such as reptiles are basically broadly sensitive across the whole spectrum. So the whole graph is elevated, but it's got a very low slope. Birds, of course, the focus for today's group, are kind of in the middle there. They've got certainly more sensitivity to blue wavelengths, and the graph is still fairly high across the whole graph. Like the line is, even at the red end of the spectrum, is over 0.5. Further on the next steps, and this is where I'm going to put on my Royal Astronomical Society of Canada hat for a moment, talking about our dark sky program. And so we're pleased that we have a very long-term program. It was actually the first dark sky program, site program in the world. Subsequently, the International Dark Sky Association, now Dark Sky International, has implemented their own program. You may have heard of that one, but we were there first, and we still think we're leading in the technical side of things. So last year was the 25th anniversary of our program, and so the program basically has a goal of recognizing and protecting dark skies for astronomical observation, at least initially. That was the thing. I've modified the slide and forgot to say we have 4 classes of parks now, because we've just added the Nocturnal Sanctuary on the bottom, and that's the one I want to focus on here. But we have dark sky preserves, pristine skies away from cities, good access for astronomy observations and so on. The Urban Star Park was for more light polluted areas and a bit more accessible. It can be a bit of an elitist hobby if you need to travel several hours away from your home to find dark skies, but we're trying to protect astronomical observation sites closer into cities, so it's a bit more accessible. We also have a nocturnal preserve, where in this case there's no access for astronomy. The whole focus is on the nighttime ecology, and the new site designation is called Nocturnal Sanctuary, and it's basically for urban parks without access for astronomy. And so there's no need to have people coming through at night. There's no need for access. The idea is that you're protecting this area in an urban setting strictly for the nighttime ecology. Our program basically recognizes sites that contribute to the reduction of light pollution, educate the public about dark skies, liaise with municipalities to try to get them to use more responsible lighting, increase the public awareness of the impacts of light pollution, and we're always trying to expand that network of sites to protect dark skies and the nocturnal environment. And again, the RASC, or Royal Astronomical Society of Canada, Dark Sky Site Program was the first to really emphasize the nocturnal environment, and other organizations around the world have now followed suit. So, what does it take to be a dark sky site recognized by us? Well, on-site lighting must be full cutoff, which means no light above the horizontal, and shining only where needed and only impact a small part of the park. The light spectrum has to minimize that blue. We are encouraging lighting curfews, and lighting on adjacent lands must not pass on to the observing or conservation areas of the park. And so here is an example of a site where under very good lighting, you do not see the light bulb. If you see the light bulb, chances are you're dealing with glare. Here the light is shining on the ground and targeting that and minimizing the light straight into your eyes. So that's an example of really good lighting. Similar to what I have on my house, actually. So we've got these different designations, and I want to focus in on the Nocturnal Sanctuary because I think this is the one that might impact or be of interest to this audience. Essentially, our goal is strictly to protecting a nocturnal environment in a suburban area. Sky brightness, don't worry about that. That's basically a measure of how many stars are essentially visible. And the thing here is that the astronomical viewing is optional. You do not need it. This is not about astronomy. This is about the nocturnal environment. And again, do you need accessibility to that? No. We do require parks that do to be certified to have a visitor experience program and also to engage the surrounding neighborhoods or municipalities to talk about reducing light pollution in the broader area. The Nocturnal Sanctuary, because it's about the ecology, we do actually have to think about the minimum size. And we did some work on ecological integrity and environmental patch sizes. And it turns out essentially that you need about a minimum diameter of 1 kilometer with a 100-meter wide buffer. And this allows more than 50% of a regionally available species to exist within that environment. So we minimize the light pollution in the center of this area in a way that at least most of the ecological integrity of the site is held together. I'm going to skip on that because a lot of that slide is also what I've talked about. I'm just about going to wrap up here, and I'm just going to throw some darts out across Canada on sites that I've seen that might or might not fit an example of a nocturnal sanctuary, and maybe if there's a bird team folks on the call in those areas, think about that. And so these are all sites that meet the minimum size, appear to be mostly without on-site lighting. So here in Winnipeg, Assiniboine Forest, probably the most famous urban park in the country, Rouge Urban National Park in Toronto, definitely has the minimum size necessary. Parts of the park are very narrow, but there are certain areas that are very extensive enough. Here on the West Island of Montreal, the Senneville Migratory Bird Sanctuary could qualify, as far as I can tell, as a potential site for a nocturnal sanctuary. Edmonton, Terwilliger Park. This is a beautiful setting here with the river Oxbow going around it there. Stanley Park, and in fact, Stanley Park had reached out to us a number of years back to see if parts of that park could be certified under our dark sky program, and we didn't actually have a designation that would work for it at the time, and now we have this new one, and hopefully those folks will reach out to them again and talk to them about this nocturnal sanctuary site. Fish Creek in my home city here, Fish Creek Provincial Park has large areas. Much of it is again a little too narrow, but there are some big areas that have the lateral extent to become a nocturnal sanctuary. I actually deliberately left off. We actually are working with one park in Calgary that is most of the way to getting certification underway. And so I don't want to name names there, but I'm very excited about that and some good close friends involved in that one, who might even be on the call for all I know. So if you're looking at perhaps looking at getting some points here where you can't get points elsewhere. Um, we have a light pollution strategy and supports actions to reduce light pollution. I would suggest that if you do actually get a park certified by the Royal Astronomical Society of Canada as a nocturnal sanctuary, that you would probably get a point here, even if nothing else is going your way in your municipality. Finally, don't let light pollution erase the birds. Lights Out Canada during the spring migration and during the fall migration. And we're basically in our fall migration window right now. And also, don't forget to mark your windows, folks. Save those birds. And we're right at the end here. Sometimes light can obscure the things you really need to see. And then some contact stuff, and I'm going to leave it right there and turn you back to Autumn.
Thank you so much, Roland. I really learned a lot from your presentation. Love the suggestions at the end, the little animations. Thank you so much for taking the time today. I know I'm not the only one who learned a lot. Tiffany right now is saying, thanks, Roland. This was a fantastic presentation. Before I invite folks to go off mute to ask any questions, I'll just get to the ones that we received in the chat so far for you, Roland, if that's okay.
Yeah, let's start with those.
Awesome. So, we have from James, has there been any inroads getting the oil gas sector to reduce nighttime flaring during migratory season?
I'm going to say no. The company I work for is sensitive to this issue. And I do know, like, for example, they are turning off the lights on a facility near one of our sites where we're doing an astronomy star party later this month, and they've already agreed to do that. I saw James, it might be the same James, reference Jevon's paradox. I almost used those exact words in the talk there, James. Yeah, Jevon's paradox was kind of about steam engines back in the early days of the Industrial Revolution. And a more efficient steam engine was going to reduce the need for more steam engines, and instead what happened was the Industrial Revolution. People just leave LEDs on all the time, as James says there. Okay, more questions from Autumn.
For sure. From Diana, is there documentation of the effect of greenhouses that are lit all night? Point Pelee is near Leamington, the tomato capital of Canada, which has many such greenhouses. The sky glows pink at night because of them.
Yes, greenhouses are a real big problem, particularly in Leamington, Kingsville area in Ontario. We do see the impacts of that light at the north end of Point Pelee Park, which is one of our dark sky preserves, certified by the Royal Astronomical Society of Canada. I am working on, and unfortunately it's taken me a long time, but I've probably for like 5 years now, working on regulations for minimizing light pollution from greenhouses, particularly using screens and trying to figure out a way to keep the light inside and be more efficient about how much light is actually necessary at these sites. But it is a big problem. People think of agriculture as, a farm with a tractor and so on, but these are big industrial complexes, and this agriculture has a huge impact on the local environment. So hopefully we'll, in the next year or so, roll out our recommended practices for greenhouse lighting here in Canada.
Thanks, Roland. That's a great answer. Penny, I might have missed what image you're referencing to. Would you mind coming off mute in regards to, can we get this image to edit for our community, please? If you're still here. Penny's still here. Okay. Oh, yeah, Penny's still here. Give her a moment.
Oh, sorry, Autumn. I thought I had my space bar down. Didn't work.
No worries.
A great presentation, thank you. The image that I was referring to was the little cartoony one with the kids in bed, almost like a poster, fall and spring migration.
Sure. I don't want to speak completely out of turn here. That is one we created here with our bird friendly city team, but I suspect that that would be a yes to get that. And it was created in Canva, so I suspect if we are going to release it, we'll probably release the whole file as an editable format. But I don't know if some of my colleagues are on the call here today, but for sure we can have that conversation.
That would be great. I'd actually I'm can just sharing it in Canva with me would be great. I can put our email address in the chat.
All right, that's another one
Sounds
taken care
good.
of.
So from Catherine, how does the Royal Astronomical Society of Canada respond to parks departments insisting that lights are needed in parks after hours because of crime prevention through environmental design principles? And for folks who might not know, that's Catherine has kindly linked that as well in her question.
Okay, well, so ironically, crime prevention through environmental design was more or less created in Calgary. And more than 20 years ago, attended a workshop where they were updating to like second generation septet, as it's pronounced. And they were de-emphasizing the amount of light, the importance of light at that time. So that's 20 years ago. If you go to any police service and most government parks and so on, they are still looking at first generation septet, which says adequate light for surveillance. And I think the word adequate is actually in the quote there. So we've been trying to convince people that the science doesn't support the septet original generation. So stuff that would have been from the 1980s, 1990s, and so on. And already by about the year 2000, they were de-emphasizing the amount of light. We have had other similar problems with the roadway lighting because the Transportation Association of Canada has specified certain minimum levels of lighting for roadways, which are based on, in part, the lighting recommendations from the Illuminating Engineering Society of North America. And again, there isn't a ton of actual science base for those levels, it turns out. It was just that they codified something that was common practice. And yes, we're always facing that issue with parks, particularly with Parks Canada, looking at government regulations. And so, yeah, we have not had a ton of success with some parks, and other parks are going, hey, we recognize that this is a gray area in terms of, what is recommended versus what is actually proven to be proper. I don't know if that really answers anything, but yeah, it's one we've been struggling with. And Autumn, you're muted.
Oops, sorry about that. Thanks, Roland. I'm going to pass it over to Allie, who has their hand up.
Thanks, Autumn, and thanks, Roland, for the presentation. I was just wondering what your advice would be for a municipality. So we had a council motion brought forward to develop a dark sky bylaw. That was sort of revised down. The actual motion ended up, there was a lot of concerns about a bylaw and enforcement and what would that look like. And so that kind of got softened to developing kind of a dark sky policy or strategy or some kind of framework for the municipality. And I'm just wondering, I guess, from your work in Calgary and others you've seen, like, what would maybe be some first steps that you would really focus on for a municipality kind of just entering the space? We do have some standard, like green development standards that speak to lighting. But we also, I'm in Caledon where, half the municipality is green belt, agriculture, natural areas. Like, So maybe potential for looking at dark sky preserves or site areas. But yeah, I'm curious what are some of the first steps or easier steps to at least start that process?
Yeah,
Sorry, big
that's a
question.
great question. Yeah, it's a big question. It's a great one. And having worked in Calgary for 30 years on these issues, I know it's not an easy one. Um, it depends also, I guess, on the mindset of your local council. We are working with a town council in British Columbia who are working towards to be our first dark sky community, which will be a new designation, hopefully approved within a month. Um, and so that is like a really a nature focused community, and they've just been pushing to become a dark sky community. And so that's great. In Calgary, it's been a little bit more difficult. We had a number of, and I had a list of on my slide, different places where we had things related to light pollution and light controls. We actually had something called a bright skies initiative, which was kind of an overarching thing where it was kind of aspirational words, and this would sit above all your bylaws and other documents. But basically, put in aspirational language towards reducing light pollution, minimizing your environmental impact. And if your city or municipality already has something about being environmentally friendly, just see if you can shoehorn a little bit of wording in about light pollution into that same place. It's a one good place to start because then, um, you know, it allows you to have at least a benchmark of, what do we say we stand for as a community, and what is this, new development actually doing? How does it stand up against? We then, and many communities might have this in a different place, but we, in our community standards by law, I mentioned the light trespass, where in that case, we didn't get all the wording we wanted in, but the lighting is not allowed to go from one property into the dwelling spaces of an adjacent residence. We wanted to include things like the backyard and so on, but the final version of the bylaw just had the dwelling spaces. We have that sitting in Calgary in the community standards bylaw, and then there's land use bylaws about trespass and brightness and more prescriptive type stuff. This is tricky because I know we've been working with Foothills County, which is adjacent to Calgary, and they have a light pollution bylaw as well. And there's been a lot of pushback because the bylaw officers finding it very difficult to kind of quantify how to enforce that. And so there's been pushback from administration, even though there are a number of councillors there who are very pro light pollution control. I would say maybe reach out to me more specifically, and maybe we can plan a course through all of the issues around this. But yeah, there's no straightforward, simple ones, particularly if there's a few people who are not keen on it.
Yeah, that's really helpful. I know it's something we've been kind of plugging away at slowly. And we have components here and there, like some policies speak in our official plans, some things in our green standards, but it's anything from like a retrofit basis. And we also have the issue, I don't know if others have experienced, where all of the giant estate homes, and they light up like a fire. Like it's almost absurd how much lighting is on the exterior of some of these kind of mega homes in the rural areas, where it's probably even more problematic um, than in the urban areas. So yeah, I don't know if there's like, targeting certain areas or to have different lighting
Yeah,
levels,
oh,
maybe a way
this
to.
for sure. The impact of bad lighting in a rural area quite often is more stands out a lot more than in urban areas, even though it might not look all that worse compared to some of the urban commercial districts. But in an urban setting, if there's no other light sources around it, and this is the case, we've been working with Foothills County, it happens to house both the University of Calgary's observatory, but my own club's observatory within the confines of the county. And so, we do want to control light pollution. But yeah, people, attractive environments with lighting can be done smartly without creating all these other issues of trespass and glare and overlighting. Because one of the issues you don't want to do is add so much light that anything outside the lit area is now completely dark and impenetrable. You cannot see into those. That's actually
Yeah.
creating a bigger hazard by having that contrast in light levels. Yeah.
Well, thank you very much. I might be bugging you in the near future.
Okay. No, I'm happy to be bugged.
Thanks, Ali. And Roland, maybe if you don't mind, would you be comfortable with putting your email in the chat?
I think I could do that.
Amazing. And we have a question from Penny. Interested in a dark sky policy for smaller communities, or, myself building off of that. Is there a way to adapt policies like the one in Calgary or other larger centers for smaller communities?
Yeah, and we thought we were gonna get approved actually a couple of days ago on our dark sky community designation. And within that, even if you don't go the whole hog on everything there, what you would have is a bit of a cookbook on how to write your bylaws and other things to think about. Um, so I'm hopeful, within a month or two, we will be able to share that new dark sky community designation, and therefore there's a bit of a toolkit that you can pick and choose and decide, how far along that process you want to go. Um, if you just want to make sure your town's a bit more bird friendly than the next town over, that's great. And if you want to go right into getting certified by the Royal Astronomical Society of Canada, that's fine as well. And I see Penny asking the question, perhaps a small community in BC is willing to share theirs as well. Absolutely. I'm pretty sure that's going to be the case. Um, I know that because one of the primary pushers there was a former national president of our society. So pretty sure that once they're ready to go, all those resources would be available.
Thanks again. Just following up on Penny's question there from the chat, in case you can't see it, Roland. Perhaps a small community in BC is willing
Oh
to
no,
share. Oh, you got that one.
I just spoke to that topic. Yeah.
Okay, cool. And Angela, would you like to go next?
Thanks. Yeah, this is really interesting. I'm definitely going to pass that information on about Stanley Park because I know it's sort of been an outstanding item from conversations we've had here in Vancouver. So thanks for that. I
Yeah, apologies for not being ready to accept initially, what was proposed, and then we just didn't have a place to put it, that would not dilute the other categories, but also, recognize this type of park as its own type of entity. So, yeah, apologies for not being able to follow through at the time when the park people reached out.
Oh, no worries. I think it's part of the process, right? That's how you realize there needs to be more kind of opportunity options and stuff like that. So, I had a
Yes.
separate question though, because I missed the start of the presentation. Sorry about that, but I caught the part about the robins and the blackbirds and showing that data and everything. And then just to tie it to the end of your discussion when we're talking about the 3000K and lower and the 2100K and all of that, like if you're using bulbs that are like 2300, like the old sodium lights and et cetera, would that change those kinds of impacts that you were presenting in the robins and blackbirds, basically?
Yes, because they would have a lot less blue content, and it's that blue that's messing with the circadian rhythm.
Okay.
So
Okay.
if you ever want to know well, you've probably seen some of these failed streetlights, and they look kind of bluish purple. That's when
Yes.
the phosphor has failed. And so all of those white LED streetlights are actually blue, and then you just have the phosphor to convert that. In a way, the concept is similar to the fluorescent tubes that you might have in industrial settings or your offices, where in that case, the original light source was actually ultraviolet, and then they used this fluorescing coating of phosphors inside the tube to convert that ultraviolet to visible. With the LEDs, the blue LEDs are what's creating the short wavelengths that get converted to the long wavelengths with the phosphors. Anyway,
Okay.
yes.
Thank you.
But yeah, the high pressure sodium ones, they have much less blue. The impact on the circadian rhythm was much less. The impact on the glare response was much less. Yeah, it's that blue that's really problematic. And blue is good during the daytime. It's just blue at night is what we want to avoid. And usually most of the time we're talking about lighting at night, you know. But I've got bluish lights in my office above me right now because it's daytime and I need that blue to stay alert.
That makes me think of I used to have glasses with the blue lights, like reflectors, to try to make my eyes less tired. So I've always wondered if that is real or not.
It is real. Yeah, the blue is high energy, and for vision, we don't really need that much blue. I didn't show it in the graph, but the blue response of our cone cells is actually very minimal. It's our brain does a lot of photoshopping, so to speak, to boost the small amount of blue that it actually senses to create our color vision. Most of the blue light that goes into the eye is actually used for our circadian and glare response, and very little is actually used for vision.
Good to know. Do folks have any other questions for Roland before I have a quick little update and we wrap up today's meeting? No? Okay, no worries. Thanks again, Roland, for your amazing presentation. Looking forward to what's to come next. Looking forward to hear who reaches out to you and what other communities we can get involved in this work. I'm going to stop the recording right now.